Now parabolas are given, right? So they gave us the equation of the parabola. This is the same question as this. They could also ask you, could you graph y equals the square root of x minus 3 squared minus 4? All in the square root. You could get this question written this way. If you had it written this way, what would you have to do first? You would first have to draw x minus 3 squared minus 4. That's your x squared graph. Moved 3 to the right and down 4. Do you see that that matches up with this? After doing that, you would have to make sure that you could find where your x-intercepts are. And then when you go to draw your square root graph, step 1 is find wherever your y values are 0 and wherever they're 1, those points will stay the same. Are there any other nice square roots you could do? Well, it looks like it's the red graph is equal to 4 right there, so I could make it equal to 2 right there, and it's equal to 4 again there. Now, when we draw our graph, between 0 and 1 has to be slightly above. Can you see in this situation it's very hard to go slightly above without going back in time or forward in time, right? I'm not allowed to cross this x equals 5 line, right? Anything going back like that will lose me marks. So almost the only option I have is like almost to draw the same line on top. Don't be lazy, don't be quick in these things. Pay attention to details. Sometimes the best you can do with a sharp pencil is almost go directly on top. The danger is people want to exaggerate that it goes, that would lose a half mark. They want to exaggerate that it's above, which is good that you want to show that you know that it needs to be above, because that's usually worth 1 mark. But if you go back in time, you lose a half a mark for carelessness. Don't be careless. And then this part will be below. Nothing in between 1 and 5, because our square root graph is a negative there. Ooh, I kind of like this graph. Does this look like a deer? Antlers? A little bit? Maybe? I don't know. Next graph. Is it dragon? Ooh. Okay. Next graph. So this could be the same as y equals negative x squared plus 9. You see that's a parabola that's been flipped down and shifted up 9 units. So if you got that as a question, the first thing you would do is you would graph negative x squared plus 9, which is the graph in red. Then, wherever the graph is 0, and wherever the graph is 1, square root of 0 is still 0, square root of 1 is still 1, those points will stay the same. Do we have any other nice points? Well, the y value looks like it's 4 here, so I could label 2 there and 2 there. And the y value is 9 up here, so that'll be 3. Again, slightly above here. Basically, all you have room to do is go right on top of the line. And then these ones here in between will connect like this. And this is the graph of the square root of negative x squared plus 9. Question asks for the domain of each of these. So for the first one, the domain is in 2 parts. And you could either write it like this. The x values are less than or equal to 1 or the x values are bigger than or equal to 5. In interval notation, this would be written like this. But your range is still y is bigger than or equal to 0. In the second one, now our domain is between -3 and 3. You could write it like that, or like that, in set notation or interval notation. And your range, your y value, are between 0 and 3. Or you could write that in interval notation as well, by writing from 0 to 3. And you can circle question 8. So again, to recap, the idea of graphing a square root is always the same. The new technique is graph the inside, what's inside your square root first. In this case, they were both parabolas. The textbook gave us the graphs. Sometimes on your exam, they will give you a graph. On the exam, when they give you graphs, they like to give you a bunch of straight lines connected into some weird shape. Once you're given the graph, or once you've drawn the graph yourself of the inside function, now we have to find out where the y values are 0 and where the y values are 1. Because if you square root where the original equation is 0, you still get 0. If you square root where the original equation was equal to 1, you still get 1. So those are the only points that don't change. Then that pattern we noticed at the beginning of class. When you square root a number bigger than 1, it gets smaller. So after 1, my blue graph is below my red graph. But when you square root a number between 0 and 1, you always get something slightly bigger. And so between 0 and 1, we have to try to draw it slightly above the red line in the space that we have. Sometimes you're going to almost draw it directly on top of it. Because some numbers, when you square root them, they don't actually change very much. Like we saw, the square root of 0.4 became 0.6. That's only up 0.2. That's hard to see on a graph.